In this video, we will be talking about z-scores, also known as standard scores. So when a set of data values are normally distributed, we can standardize each score by converting it into a z-score. By the way, when can we say that the set of data are normally distributed? That is when we sketch its frequency polygon using smooth curve and it resembles a bell shape just like this. And that if we are dealing with the results of such standardized tests. Some of the examples of this are licensure examinations, National Achievement Test, and NCAE or National Career Assessment Examination for students. These tests are standardized. Therefore, the set of data here are normally distributed. Next. So the process of changing an X value or the row score into a Z-score involves creating a sign number called Z-score such that the sign of the z-score, which is positive or negative, identifies whether the x value or the row score is located above the mean if that is positive and below the mean if it's negative. And the numerical value of the z-score corresponds to the number of standard deviations between x or the row score and the mean of the distribution. So, kung ano yung value ng z-score natin, yan din ang number ng standard deviation between the score and the mean. Now, let's define z-scores. Z-scores is the process of standardization or just putting scores on a test into a form which we can use to compare across tests. So this score is also known as standard scores. It is a measure of relative standing. What is a relative standing? So relative standing is the position of your score in a set of data. So out of 100 students, so where does your score located? Is it above the mean or below the mean? Okay, so this course represents distances between a given measurement x and the mean from the center measured in standard deviation units. So it is measured in standard deviation units, the z-score or standard score. Next, so we have here a measure. It is also a measure of an observation's distance from the mean, of course. And the distance, of course, is measured by standard deviation units. The standard score, it measures how many standard deviations a given value of x or row score is above or below the mean. So that is the purpose. Okay, so now let's talk about the importance of z-scores. So z-scores make it easier to compare data values measured on different scales. So when you say different scales, it talks about nominal, ordinal, interval, and ratio scales or level of measurements, which we talked about on our previous topic. So the fact that z-scores identify exact locations within a distribution, it means that z-scores can be used as we have descriptive statistics and as inferential statistics. So when we say statistics, it is just a representative that will represent the whole data or the population. So for descriptive statistics, z-scores describe exactly where each individual score is located. So the z-score measures are useful in comparing observed values. When it talks about research, and then a positive one, it indicates that the score or observed value is above the mean, and the negative z-score indicates that the score is below the mean. Now, if the score is 0, it means that it's on the mean or at the center. If a z-score is 1, it's 1 standard deviation above the mean. And if the z-score is negative 2, it only means that it's 2 standard deviation units below the mean. So that's how we interpret the value of z-score. Now, as inferential statistics, z-scores determine whether a specific sample is a representative of its population or is extreme and unrepresentative. Okay, here we are deciding kung ang data ba na yun ay magre-represent sa whole data ng ating population or not. Okay. Now, here are the formulas in computing for the value of z-score. So we have here z-score for population data and z-score for sample data. And we also have here the formula computing for the row score. So here are the symbols being used. So capital letter X is the given measurement, that is the row score. Mu is the population mean. Lowercase sigma, it refers to population standard deviation. We have here, this is the sample mean, and small letter s is for the sample standard deviation. This time, let's solve some problems. So on a final examination in biology, the mean was 75 and the standard deviation is 12. Determine the standard score of a student who received a score of 60, assuming that the scores are normally distributed. So in this word problem, we are going to identify first what are the given. So the given are the mean, it's the sample mean, which is 75. The standard deviation is 12. The row score is 60. And the z-score is missing. So we're going to have to use the formula for the sample, using the sample data. So x minus mean divided by standard deviation. Then we're going to substitute the given values on our formula. So for row score, we have 60 rather, minus the mean, which is 75, divided by the standard deviation, which is 12. So 60 minus 75, that is negative 15, divided by 12. So by division, so z is equal to negative 1.25. So this is now the z-score. So how can we interpret this data? So our interpretation would be, therefore, the student score of 60 is 1.25 standard deviation below the mean. So this is how we're going to interpret the data. Since that is negative, therefore, its location is below the mean. And the z-score, we are using here standard deviation as the measurement, the unit for measurement. Next. Second example, on the first periodic exam in statistics, the population mean was 70 and the population standard deviation was 9. Determine the standard score of a student who got a score of 88, assuming that the scores are normally distributed again. So first step is to identify the given. So since we have here the keyword population, then our given are population mean, which is 70, population standard deviation 9, the row score 88, and the z-score is missing. So we're going to have to use the formula for the population data. X minus mean over standard deviation, and substitute the given values that we have here on the given. So for row score, we have 88 minus the mean, which is 70, divided by 9 as our standard deviation. So 88 minus 70, that is 18, then divide it by 9. So 18 divided by 9, that is equal to 2. So z is equal to 2. So our interpretation would be, therefore, the student score of 88 is 2 standard deviation above the mean. So that's how we interpret the data. Okay, let's proceed. In a job fair, 4,000 applicants applied for a job. Their mean age was found to be 28 with standard deviation of 4 years. Our task here is to draw a normal curve distribution showing the z-scores and the row scores. Of course, the first thing to do is to draw a normal curve and put the labels for the z-scores. Take note that at the center of the curve, here lies the mean. And in our given, we have here the mean age, which is 28. So we should have to write here the number 28 as the mean age. And for us to determine the row scores, corresponds each z-scores to the left and to the right of the curve, we should have to take the value of the standard deviation, which is 4, since it dictates the distance of the row score from the mean. So from the mean going to the left, we should have to subtract 4. And from the mean going to the right, we should have to add 4 from each row score. Okay, so let's begin with the row scores to the right of the mean. So at z equals 1, or 1 standard deviation to the right of the mean, we have to add 4 to 28. So 28 plus 4, that is 32. Then, at z equals positive 2, so we should have to add 4 to 32. Then it is equal to 36. The row score is 36. And for the row score of z equals 3, we should have to add 4 to 36. Then, the row score is 40. Now, let's proceed on the row scores of the left side of the curve. So from 28, we should have to subtract 4. So 28 minus 4, that is 24. 24 is the row score, corresponds z equals -1. And at z equals -2, the row score is 20. That is by 24 minus 4. Then 20 minus 4, we have 16 as the row score corresponding the z equals -3. Then we're done doing this task. Okay, next. Given the same problem or situation, let's answer this question. How many applicants are below 24 years old? And to answer this question, we must take the normal curve with the row scores we have a while ago. So 24 years old is located here, below the mean or to the to the left of the mean at z equals -1. So our problem here requires us to know the area, okay, before z equals -1. Okay, first thing to do is to consult the z table for the corresponding area of z equals -1, and that is 0.3413. Okay, 0.3413 is the area from the mean going to z equals -1. But our question requires us to know the area before z equals -1. So we must do this step. So 0.5,000 minus the area we have, which is 0.3413. Then the remaining area is 0.1587 or 15.87%. So this is now the area, that we need to know. So how many applicants are here? So to know that, we should have to use this formula. So applicants below 24 years old is equal to, given this area or probability, that is 15.87% times the total number of applicants, which is 4,000. Then upon multiplication, it will yield to a result which is 634.8 or 635. So therefore, there are 635 applicants who are below 24 years old. So now, we already answered the question number 2. Next. So given the same situation and given values, so we have to answer question number 3. So how many have ages between 28 and 32? So we have here the same normal curve having the same row scores. So between 28 and 32. So 32, that is z equals 1. So we must know the area, okay? The number of applicants who age between 28 and 32. So the first step to do is to locate or to consult the z table for the corresponding area of z equals 1. And the area for z equals 1 is 0.3413 or 34.13%. Okay, so with that, we can now solve for the number of applicants who age between 28 and 32. So this is the formula. 34.13% times 4,000. So upon multiplication, the result is 1,365.2 or 1,365. So there were 1,365 applicants who age between 28 and 32. And that is now the answer of the question that we have here. Next. Having the same situation again, we must answer this fourth question. This is to find the age such that 85% is below it. So we also have here the same curve having the same row scores. So we must express 85% to its decimal form, which can be written as 0.8500. And since it's greater than 0.5000, then we must split that decimal. So that is equal to 0.5000 plus 0.3500. Okay, and then our question here tells us to know or to find the ages that 85% is below it. So we already have here the 0.5000. And we all know that 0.5000 is the area which is equal to the half of the curve. So where does it located? So since we have the keyword below, then the 0.5000 must be on the left side. Then we have to shade this portion. And all we need to do is to locate the z-score. Corresponds the remaining area, which is equal to 0.3500. So using our z table, we'll have to look for the two nearest area before and after the remaining area. So the nearest area before is 0.3485 corresponds to z equals 1.03. And the area nearest after the remaining area is equal to 0.3508 corresponds to z-score, which is equal to 1.04. And since the area after the remaining area is the closest one, then we will take its z value, which is 1.04, and we are going to locate that here on our curve. And here is 1.04, and we must draw vertical line and shade the part. So this is now the shaded part. So, and for us to know what is the age such that 85% is below it, then we must do the following operation. So this is the formula. So we have here 1.04 as the z-score times 4. So what is this 4? So 4 is the standard deviation. So 1.04 times 4, that is equal to 4.16 plus 28 as the mean. That is the mean. Then the age is equal to 32.16 or 32. Therefore, 32 is the age such that 85% is below it. Okay? Now, we're done answering the fourth question. So, here it ends our lesson. Okay? So, I hope you understand and you follow the steps that we did along the way. So, thank you for watching and listening.